Okay. So here's our situation. We have a delivery worker that's pushing a crate across a warehouse at a constant force of 250 newtons. But the force is being applied at an angle of 30 degrees to the horizontal. So this is the direction, 30 degrees to the horizontal. And it pushes it 15 meters horizontally. Okay. So the first thing we're being asked to do is calculate the component of the applied force that is parallel to the floor, meaning that's going this direction. Okay. So what we have to do then is realize that we're looking for the adjacent, right? So let's imagine this triangle right here, right? We have this component. We're looking for this component of the applied force. So in that case, we're going to use cosine. Okay. So if we call this x, remember for now, we're just finding the force. Yes, we have the distance, but those are two different measurements. We're looking for the force, the horizontal component. Okay. So what you want to do then is you want to say that x is going to be equal to 250 multiplied by the cosine of 30 degrees. And once you do that, you will end up with 216.5 newtons. So that takes care of part A. What's very important in part A is that you get the concepts, okay? Again, feel free to leave your comments below. Now we need to calculate the work done by the applied force in moving the crate. So now we know the component that's moving in the same direction, okay, as the distance. So the work done is going to be equal to the force times that distance. So it's going to be equal to 216.5 multiplied by 15. Again, that's because we can't use the 250 and the 15 because those are two different directions. Hence, we have to find the component in the same direction as the distance that it is being moved. And once we do that, we get 32, 47.5 joules. And part C asks us to find the power given that this was done in a particular time. And of course, power in this case is equal to work done over time, which is equal to 3247.5 over the time, which is given as 25 seconds. And when you perform that calculation, you get 129.9 watts or 129.9 joules per second.